So this is our project framework. You can see it's a very sophisticated metaphor of a sandwich that we like to use on the project. And that's because we have very important components on the project which all need to come together in order for it to work. The first bit, the top slice of the sandwich, is about the theory-driven nature of the project. We're working with the ideas of cognition and behaviour from cognitive behavioural therapy, influenced in no small part by Nirit's work in Israel, working with CBT. And basically the focus there is on the importance of learning and experience, cognition and behaviour. So children learn about various things, reflect on them, and then have the opportunity to practice and role play as well. So the idea being that it's really important to have both of those things. The filling in the sandwich is the technology requirements that we have from those two different technologies. It's the affordances of the technology. Why are we using the technologies in the first place? What are their specific advantages for these children on the autism spectrum? How can we represent information? And how can we control the interaction? So what is it that the technology gives us that might be difficult to achieve in other ways? What's the real benefit of it? And the bottom slice is our user-driven participatory methods, very similar to Karen and Wendy in the way they talked about their participatory design. We're working with young people and with teachers all the way through the project in a very iterative and close collaborative way in order to make sure that we understand how we can use these technologies in the classrooms and that we develop technologies that are going to meet appropriate educational objectives. So I'm just going to focus on the collaboration part of the project for today's talk. Social conversation is we're currently developing. And when we think about collaboration, what do we mean? Simply, it means working together on a shared activity. But it's a bit more complex than that. It's about joint engagement. It's about the reciprocity of that. So children being involved in an interactive social task that will include or require them to take joint perspectives through choosing, planning, communicating, and performing a social activity together. So with our technologies, and I'll tell you about the concepts in a minute, just before the summer, in Israel and in the UK undertook some pilot studies with those two technologies. And these were the questions we were interested in from the pilot studies. Does the task support collaboration and communication? Does it do what we hoped it would? Does the task encourage children to consider the perspectives of others? Is the task usable and acceptable for children? What age and ability levels are needed for successful completion of the task? And where and how is the facilitation needed, both through the computer and by the human facilitators who sit with the children? So in terms of the CVE scenario, this is the block party task. And that supports collaboration of children through perspective-taking and communication. And because it has that perspective-taking element that I've already mentioned, it's designed for that particular unique affordance of collaborative virtual environments. It's a task where children see different sides of this image on the left-hand side, and they have a target block that they have to make. They have to stack blocks up in the middle of the room. And each child has different colours at the top. So they have to talk to each other in order to make sure that they get the right blocks. And they have to move the block, they have to choose the block, move the block, rotate the block so that they can see the right colours that match their target. So basically it's about working together to try and get the right sequence and hit the right target. This is our setup for testing. You can see children are in the same room and divided by a board, so they can't see each other, and they're working with a facilitator sat alongside. We worked with 4 pairs of typically developing children who were aged 8, as well as 3 pairs of children on the autism spectrum who were aged around 11. And we took a number of cognitive and standardised assessments carried out over 3 sessions with them. I'm not going to go into the details of that today. And then the block party session with the CVE took place in a session of approximately 40 to 60 minutes. Now, we haven't had a chance to really properly analyse that data yet. There's a lot of rich video data from that. So what I'm going to give you is our initial impressions, and they are just hunches. But the typically developing children we thought engaged well with the scenario. They had few difficulties understanding the concepts or navigation. They enjoyed it, importantly, and some needed more prompting than others to get through the task because of their literacy levels. Overall, though, they felt it was too easy and they wanted more complex levels. That does get more complex up to a point, but we also need to make it more complex still so that there's more challenge for children. Children on the autism spectrum also engaged well with the task. They had few difficulties too with navigation or the concept. With one exception, one lad struggled a bit with the task. Generally, though, they struggled more with the task in terms of the level of facilitation and prompting needed from the teacher supporting them to do the task. And generally, and this won't surprise you probably, there was a greater reluctance from them to communicate with their partner, although most reported enjoying the task. We suspect what we're most likely to see are qualitative differences between the typically developing and the children on the autism spectrum. There were noticeably different styles of interaction between the pairs of children on the spectrum, including not responding to or ignoring the comments of their partner, the child they were working with, speaking very quietly, trying to go off task, so to break the rules of the task a bit, and trying to say as little as possible in order to complete the task, so keeping the communication to a minimum. So, of course, that leaves us with a challenge now about how we code and analyse the data. We need to look at the type and style of interaction and try to get at somehow this notion of reciprocity between the children, as well as how the facilitation takes place. So that's what we're working on at the moment. In terms of the shared active surfaces, there's a suite of 3 concepts at the moment, which has been the basis for the pilot study. And those games are addressing interaction and collaboration. So you have different ways of interacting with the shared active surface. The apple orchard game, both children have to move the basket together in order to catch apples from falling from the tree. On the bridge, which is the second picture down, children work on their own side of the table but have to communicate with each other in order to complete the task successfully. And on the bottom, they have different roles that they have to that they take on in order to complete the task. So you have to get the stars at the top into the boat at the bottom, and you have to work together to be able to do that. So you have to plan ahead your actions. The Israeli team worked with 5 pairs of boys on the autism spectrum, and 2 occupational therapists served as facilitators there. 5 teachers observed the use as well of the technology by 1 pair of typically developing children, had sessions that lasted about an hour, and at the end of the session, children had a debriefing interview where they gave some feedback about what they thought about the game. So again, they haven't had a chance to analyse their results either yet. And again, this is about impressions of the game. But it looks positive. There was suggestions of adaptability, so which meant that the practitioner, the facilitator working with the children around the technology, was able to adjust their responses to the individual needs and responses of the children. So that was good. It suggests there's some flexibility around the use of the technology, which is obviously beneficial. And the teachers that they worked with were also suggesting developments, improvements to the technology, which will be taken into the next stages of development. Efficacy and efficiency. According to the practitioners, the join-in tasks help children to collaborate together because they were encouraged to do so through the completion of the task. Playability. The children immediately understood how to operate the system, and they became familiar with the game rules and operations very quickly. No problem with that. And there was high levels of engagement from the children on the task, so they liked it. So the conclusion is the join-in suite was successful in coupling the attractive power of video games within an educational setting. So next steps, where do we go from here? Our second set of scenarios will focus on social conversation, so both through the collaborative virtual environments and the shared active surfaces, we're developing social conversation scenarios, and those will be pilot tested. before December. And then both teams will be embarking on a formal intervention study next year using those technologies and working mostly, I think, with pairs of children on the autism spectrum. We might also be looking at the interaction with typically developing peers as well. So watch this space, basically. We haven't got the results yet. We haven't done our formal evaluation yet. We'll be doing that next year. And then hopefully we'll be presenting those results soon. But thanks for listening. And any questions coming up next? Thanks.